Hey guys, and welcome back to our video series on Hipot testing. My name is Anthony, and last time we were in the lab here, we talked about how to Hipot test. And that means making proper connections, understanding where the voltage is being applied, and lastly, we looked at a breakdown, visually what a failed Hipot test looks like. So once we can grasp those concepts, you may have some more questions, and I think one of the big ones is, do I test in AC or DC? And so that segues us into today's video topic, AC versus DC, some pros and cons, and what's the best fit for your application. Now, before we begin contrasting AC versus DC, you want to confirm that the standard you're adhering to gives you the option to test in DC. A lot of the standards that our customers are testing to do have specific language which say, alternatively, a DC test may be performed at the equivalent AC peak voltage. Okay, so what that's saying is, if I was running a 1200 volt AC Hipot test, I can't just go ahead and turn it into DC at that same value. I need to make sure that that insulation is feeling the exact same stress as it would in the AC Hipot test. So I need to use that peak value for my DC Hipot test. So once you've confirmed that you do have that option, the next thing we need to look at is your specific device under test, the product that you're manufacturing, and is there any inherent capacitance to it? Because if there is, that's going to affect how it reacts to AC or DC voltage. So jumping right into the AC pros, one of the great things is it's a shorter test. There's no need to ramp up. Since AC naturally oscillates and ramps up, there's no need to add extra time to avoid reactive current, which could cause a false failure. This is seen a lot in DC Hipot tests. You're forced to add a ramp-up time because that spike of reactive current is just too much for the Hipot tester, and it shoots out a failure. It shoots out some sort of error code, and now you're forced to increase that time to lower the reactive current. Okay, another great thing about AC Hipot test is you're testing the insulation on both sides because polarity is switching. So in a DC Hipot test, you're kind of just hitting it from the mains to ground, where on AC, you're also coming from the ground to mains due to that change in polarity. Another great thing about AC, contrasting with DC, is when you're performing a DC test, at the end of that test, you're probably left with a charged product. And so it's imperative that you have some sort of procedure to verify that you're discharging everything that just got Hipot tested. Where in AC, since you have that natural ramp up, it's not likely at all that you're going to see that full charge that would be left on a DC Hipot test. But of course, best practice is to always make sure you have implemented a procedure that ensures the device under test is fully discharged after Hipot. Lastly, the great thing about the AC Hipot test is that it's commonly and widely accepted by all safety agencies. Okay, but it's not all negatives for DC. The great thing about the DC Hipot test is it's real, meaning all the leakage you're seeing is purely resistive. That number you're seeing on the meter on your Hipot test is actual electrons breaking through the insulations from mains to the chassis, from mains to your ground circuit, or whatever type of Hipot test you're performing. You know that that's the actual value that a customer might see when this product is in the field. Where in AC, you're getting that reactive current as well. It's a composite of reactive and real. So you're not entirely sure if the current you're seeing is what the end user is going to see in the field, or is it just a large portion of reactive current added to that resistive current. And since we're using less current, it's way more cost effective because you can now buy a standalone DC Hipot tester. So if you can get away with just performing the DC Hipot, you're in a great spot to just buy one of our standalone benchtop DC testers as opposed to our AC, which is going to come with a lot more capabilities and the price tag is going to be a little bit higher. Lastly, while this isn't a pro, I just want to reiterate that we want to make sure if you're going to perform the DC Hipot test, verify that it's accepted under the standard you're abiding to, and when you've completed that test, even larger concern is to verify that your procedure is in place to make sure that you're discharging all these products before the next operator pulls it and takes it to the next shipping station or whatnot. You want to make sure that operator is in no way in danger of getting shocked, because with DC there is no discharge due to the characteristic of the DC voltage. Now we do have some redundancies built in. We will discharge the product at the end of the test, but we have a capacitive load spec, okay? And not a lot of people look at that. If you're within a certain microfarad range and you're testing over a certain voltage, we can't guarantee that we're going to fully discharge that product. So that's called our maximum capacitive loading in DC spec. That's something you want to look into if you're going to choose to run the DC Hipot test. Okay, so going back to one of my original points, which was that reactive current that you see due to the capacitive nature of your product, this can cause false failures. And so what I want to do is perform a test on a 1 microfarad capacitor. We're going to perform it in AC, and then we're going to perform it in DC. And we're going to compare the results and see if one of us maybe got us a false failure and one of us got us through to the end. So let's go ahead and perform these tests now. All right, so as I said earlier, here we have some capacitors in parallel simulating a highly capacitive product, and we're going to run a normal AC Hipot test at 1,240 volts. That's very standard. Our high limit is at 20 milliamps. That's the most our tester can output. So again, this is simulating a customer's either highly capacitive, a motor, or 1,000 feet of cable spooled together. And we'll run this test, and you see we get a failure, an immediate failure, high limit, greater than 20 milliamps. Now that doesn't mean that 20 milliamps has somehow found a way through the insulation of the product. That just means that there's too much capacitance and the reactive current is more than this tester can handle. Okay, so that's a false failure, and that's something that customers have to deal with and now have to try to find a solution. So let's run that same test now in DC voltage. So here we are, same DUT, 1750, which is the equivalent of the AC peak voltage of the test we just ran, which is how standards outline the necessity to make sure you're testing at an equivalent voltage. Okay, so we're going to run this test, and we do see some initial charging current, but once the voltage reaches the test voltage setting, there's no more changing in voltage, so there's no more reactive current. It's all purely resistive current. And so that's actual current breaking through the insulation, which is usually 0, and you get to pass this test. Okay, so these were the major differences between AC voltage Hipot test and DC voltage. These are the key things you need to remember when choosing which test you're going to run. So understanding the capacitive nature of your DUT. If you don't have it, AC voltage is fine. If you do, attempt DC. If that doesn't work, you need to upgrade to the 500 VA model. Understand that discharging is necessary if you are going to be testing in DC and do have a capacitive nature to your product. And lastly, the 500 VA unit can output up to 100 milliamps. So that will be your last resort if the AC or DC tests don't work for you. So that was it for AC versus DC. We hope you found this information useful, and we'll see you in our next video. Thank you.